Hello students. Now we are going to start with the new topic, which is thrust and pressure. Now what is thrust? Have we heard about force? Yes, we have. Suppose this is a body of mass m and we want to push it, then we'll have to apply some force on it, and the force would be mass into acceleration, right? Now this force can be acted upon this body in any direction at any angle, but thrust is also a force, but mandatorily thrust is a perpendicular force which is acting always normal on the surface. That means if this body is applying its weight, which is equal to mg, in vertically downward direction, then this would be regarded as thrust. Thrust is the normal force. That is it. Thrust is the normal force or perpendicular force which is acting on a surface. So according to thrust, we have just changed the name of force, which is thrust now. And why are we studying about thrust? Because we want to study about pressure. Now what is pressure? Pressure is normal force acting per unit area of the body. So this is normal force acting per unit area of the body. So what is normal force? Normal force is the perpendicular force, which is thrust, and the area would be the area on which the force is being applied, and that is giving me pressure. So what would be the SI unit of pressure? Pressure is, let's say this is 1 Newton upon 1 meter square. This is called 1 Pascal. So Pascal is the SI unit of pressure. 1 Pascal is 1 Newton per meter square. That is 1 Newton of force acting normally, because we are not using F normal, we are using thrust here, and thrust is the normal force. So when 1 Newton of normal force acts on a surface of 1 meter square area, then pressure is said to be 1 Pascal. Okay, this is how pressure is applicable. Consider an example. We have a cube and it is placed on a horizontal surface. Okay, now let's say the mass of this cube is 10 kg and the dimension of the cube is length into breadth into height. So this length, let us say this is also 10 meter. Cube has each side equal in length. Okay, now I want to find the pressure which this cube is applying on the base or the horizontal surface. What would be pressure? Pressure is force per unit area. What is the force which this cube will be applying? Force is the weight of the body, which is mg, so that is 10 into 10, this much newtons, upon what would be area? For area we are going to take the bottom base only, because this is the area which is in contact with the surface. So what is the area of the bottom face of the cube? This is 10 into 10, that is 100 meters square, right? So we'll get pressure is equal to 1 Pascal or 1 Newton per meter square. So you should not say 1 Newton per meter square. Here onwards we'll say 1 Pascal. So pressure is always normal force per unit area. Now, do liquids apply pressure, or are these liquids any kind of liquid? Let's say water. Are this liquid they are capable enough to apply pressure on any body? Yes, they are. Why? Because in case of liquid, the force applied by liquid is always in perpendicular direction with the surface of the container in which they are placed in. So that is why we are going to study about liquid pressure. So consider a beaker and it is enclosing some volume of liquid. This much liquid is contained in the beaker. Okay. Now at any point, let us say at any point, we want to talk about pressure. Okay. Now pressure consists of a normal force and which is acting in some unit area, right? First we will be describing about whether this liquid is applying force in any normal direction or not, because that is very important. Okay, now we do know that this liquid will definitely have some mass, due to which it will have some weight, and the weight will be applicable on the bottom face of the this container. That is true. So one thing is sure, that force is there. We are not sure yet whether the force is normal or not. Okay, let us say the force applied by liquid is not normal, let us say, okay? Force is not normal. So if the force is not normal, then the force will also cause some normal reaction, the reaction opposite to and equal to the force applied by liquid, okay? Now, if there is a reaction in this direction, that means the liquid will tend to move, because liquid is what? It is a fluid. Fluid can move in any direction where the force is applicable. So this normal reaction will cause there some motion in the fluid in this direction, right? So if a liquid is contained in a container, still it will try to move, right? You can see the waves coming out of it, but that doesn't happen. That means this force doesn't exist, and that means the force is not in any angular direction, it is always in perpendicular directions. So this proves theoretically. I have a numerical proof as well in terms of expressions, but that we are going to do in our higher classes. So right now we are satisfied with the theoretical proof that yes, liquid apply force, and that too always in perpendicular direction. So the force applied by liquids is in perpendicular direction. Second, the fluid also applies this force in any area. That is why the pressure is termed. That is what called as liquid pressure, okay? So what is liquid pressure? It is the pressure applied by the liquid on the walls of container in which it is enclosed in, and it is always, liquid always applies normal force, right? Now, have you heard about the fact, or you might have experience about the fact, that when you go to swimming or anything is dipped in a liquid, the weight gets a bit lighter, right? So liquid try to push us back in the air with some force. So where is that force coming up from? That force, my friend, is called buoyant force. So now we are going to study about the principle which is called buoyancy. What is buoyancy? Buoyancy is an upward force applied by liquid on any body on which, if the body is immersed in the liquid. That is, consider the same example. It is filled with liquid, okay, this container, and I have this random body, okay. So this random body, I am suspending this body inside this liquid. So right now, suppose you have those measuring scales units on which you measure any weight. There is a small scale pendulum in which you lift the weight and it will show you what is the weight of the body. So suppose I place that needle here and I am getting some reading that the mass of the body is this much, but after immersing in liquid, the needle will show a bit lesser value. That means the weight got decreased. How can weight of the body decrease? Mass is the quantity of matter contained in a body, mass cannot change. That means there must be some opposite force which is acting on the body to lift the body upwards. So that means the body is already getting some support from the bottom, and that is why the weight is getting decreased. So this proves the fact of buoyancy. So what is buoyancy or buoyant force? Buoyant force is the force acting on any body in upward direction which is immersed in a fluid or liquid. Fluids, even gases are considered to be fluid, so I have to precisely mention the word a liquid after fluid, because the buoyant force is more experienced in liquid as in air. Even in air we experience this buoyant force, but it is so small that it is almost negligible, right? So buoyant force is an upward force, or it is also referred as upthrust, experienced by a body which is immersed in a fluid, okay. So according to buoyant force, you can and we can now discuss about the law of flotation. Okay, I'm going to do it here only. What do you mean by law of flotation? Suppose I have a small body, circular body, okay, and I'm going to put it in a liquid. There are three cases that, number one, the body will remain on the top, that means it will not sink at all. The second case may be the body is partially inside the liquid and partially on the top, that is it is floating. This is completely not sinking, that is floating, completely floating. This is semi floating or half sink. And the third case might be the body may sink. What can cause these effects? Why can bodies sink? So the fact is, in each case there was a weight acting on the body, on the fluid, and there was an upthrust acting on the body. Upthrust, that is upward force, right? So now we know if weight is greater than upthrust, body will float on the surface. If weight is equal to upthrust, the body will float partially in the fluid. That is the case of ice. When you dip an ice cube in the glass, you will see the ice cube is floating on the top, but it is also partially immersed. And lastly, the body will sink if the weight is less than the upthrust. So if weight increases, the body will sink. This is all about the law of flotation.